Next, we're going to discuss how to graph the simplest family of power functions. The simplest family of power functions are the ones where the exponent is just a whole number. And in order to see what these graphs look like, let's look at this pattern here. We have, that's a familiar graph, that's a parabola. And then we have x cubed, which looks very, very different. But then x to the fourth looks kind of like x squared did, just sort of fatter at the bottom and narrower at the top, so more sort of rectangular. And x to the fifth looks a lot like x to the third did, though again, wider at the bottom and narrower at the top, so more square-cornered looking. And that's the pattern we see. If n is even, then the graph is a U-shaped curve. Now notice, not every U-shaped curve is a parabola. It's only a parabola if we have x squared. So this is not a parabola. A parabola is a very specific geometric shape, and not every U-shaped curve has it. But if we have an even power of x, its graph is a U-shaped curve, and it passes through 0, 0. To the left of 0, we have -1, 1. And to the right of 0, we have +1, 1. If our exponent is odd, on the other hand, we get this kind of S-shaped curve. And S is an approximation because they're functions, so they pass the vertical line test. But you can think of those as kind of an S-shaped curve. And again, it passes through 0, 0, because 0 to any power gives us 0. And then it passes through 1, 1, because 1 to any power gives us 1. But then when x is -1, an odd power gives us -1 back. So that's the key difference. The even powers pass through -1, 1, which means they go up on both sides, whereas the odd powers pass through -1, -1, which means they go up to the right and down to the left. Other than being even or odd, the effect that the value of n has is that the larger of the value of n, the flatter and steeper the way the graph turns. So in x squared, we just kind of lightly turn around at the x-axis. In x to the fourth, we have a more flat bottom and then steeper sides. If we're composing with something linear, then we keep the general shape. But if we're subtracting h and adding k, then the turn happens at hk, where we're taking the nth power of 0. And then we're adding k to the 0 we get as a result. And the other thing that we need to keep track of is that if a is a negative number, then the graph is upside down. So to keep track of that, and also how wide and flat it is, we'll put our turn at h, k, and then we'll use 2 points to either side of that in order to draw our graph. Okay, so let's draw one of these. And notice that I haven't drawn my axes yet. When I go to draw a graph, I want to make a plan before I draw my x and y axis. So here we have our values of h and k, right? We have x minus 2, x plus 1. So h is 2, k is 1. 2, 1 is going to be like my middle point. And then just to see what happens, I'm going to take 1 and 0, which are the numbers less than 2. 3 and 4, which are the numbers more than 2. And then I'm going to find the value of my y. Now to find my y values, I'm just going to plug those into my function. So when x is 0, I have -1/2 times 0 minus 2 to the third plus 1. Putting that into my calculator, I have a +5. When x is 1, I have -1/2 times 1 minus 2 to the third plus 1. Putting that into my calculator, I get 3/2. But I know I'm going to be graphing, so I like mixed numbers. That's 1/2. Putting in 3, I have -1/2 times 3 minus 2 to the third plus 1. And that's going to work out to +1/2. And finally, -1/2 times 4 minus 2 to the third plus 1. That gives me a -3. Okay, now I've figured out what values I'm interested in. I can actually draw my axes. My y-axis needs to go from +5 at the top down to a -3 at the bottom. Let's see if I just have enough space to do that if I'm just counting by ones. So I'll start with +5 at the top. 4, 3, 2, 1. And then I'll have a -1, -2, -3. Okay, so I have exactly enough space vertically to do that. My x-axis, I've got some more leeway. My x's need to go up to +4, since I have a little bit more leeway and since that's a little bit shorter. I'm going to extend that beyond in both directions. So I'm going to show a negative number for x. And then I've got 1, 2, 3, 4, 5. And I won't forget to label my axes, x and y. Okay, time to plot our points now. And I don't love plotting these fractions, but since I do have some integer pairs and halves aren't that bad to plot, I'm definitely not going to extend this to be twice as tall in order to have tick marks on the 1/2, because I don't have room for that. So let's see. I'm going to plot my 2, 1 first, because I'm thinking of this as being kind of in the middle of that S-shaped curve that I know I'm going to get for the third power. And then 1, 1.5 is going to look like that. 3.5 is going to look like that. And then 0, 5, that's going to be up here. And 4, -3, that's down here. And I might be tempted to draw like a zigzag, because it looks like those 3 points lie on a straight line. But I know I'm going to have an S-shaped curve, so I'm not going to do that. Instead, I'm going to try to draw kind of a smooth curve that goes through these points. It's got a little twist in the middle there, and I know it flattens out at that turning point, and then it comes down, and it'll look something like that. There's our graph of y equals f of x. So, the points we got helped guide us on where we were and how big our curve was. And notice this is upside down, as we would have expected, because -1/2 is negative. So that's exactly what we expected to happen. And all of those points work out for us.